Alright, so we're going to be talking about double and half angle identities. You guys are going to be able to solve equations and find exact values using these new identities. These are identities that you do not have to memorize, so that's why you have the little card. That card is going to join the sum and difference identities that are in your pocket. Okay? Please make sure you guys are keeping up with that, keeping that pocket closed, so that way you don't lose any of your identities. Okay? So, your double angle identities. We'll start with those first. Okay? Those are the ones that you see here that are on that slip of paper. I just realized I'm not putting on half angle, so I do apologize. You'll have to write those down by hand. The ones that are on the cards, these are your double angle identities. You see there's one for sine, one for cosine, and one for tangent. This 2 is not a square. This 2 is like a normal full-size 2 that's on the same line as cosine and u. It's not squared. It's a normal 2. So whenever you see sine 2x, or sine 2u, or sine 2 alpha, or sine 2 beta, or sine 2 theta, or any other variable, that means you're using this identity. You're going to replace sine of 2u with 2 sine u cosine. Cosine 2u, the double angle for cosine, has 3 different identities. Okay? No, you will not use all 3 at the same time. You'll look at your equation that you're dealing with, and then you'll choose which one is the better one to use. Yes?
Would they all work for any equation?
Yes. However, one will work easier than the others. So for example, say you had an equation that was like cosine 2x minus cosine x plus 2 equals 0. You are going to replace this double angle identity with one of the 3. Which one do you think will be the better one to replace it with? The second one, because you already have a regular cosine there, and so it makes the most sense to use the one that has the cosine only in it. If it was the other way, say this was a sine instead, you would want to use the bottom one. I would try to save the one at the top as the very last option, unless you have a cosine squared x and a sine squared x in the problem as well. That's the only time when I would use the one at the top. Okay? And then there's the one for tangent. Alright? Let's look at some equations. This should span between pages 41 and 42. Okay? So, if you want to make 41 all your double angle, that's fine. 42 all your half angle, that's fine. But make sure we're using 2 pages, 41 and 42 today. We're going to solve each of these equations for the domain 0 to 2 pi. So, we have tangent 2x plus tan x equals 0. We have to solve this. No, you cannot condense this and say this is tangent 3x. It doesn't work that way. Okay? But you can replace tangent 2x with that double angle identity for tangent. Does everybody see it in the card? That is a 2 tangent u, but I'm not going to put a u. I put an x, because I'm dealing with x's. All over 1 minus 2 tangent squared x. Ought to be what? Oh, sorry, not the 2. I don't know why I put the 2. I apologize. I don't know why. I think I looked up and then it was like, I apologize. After that, I have all tangents now. Now it's a matter of solving this equation. Okay? How would I solve this? Say again? I can get a common denominator of a 1 minus tangent squared x. So that means I have to multiply this term by a 1 minus tangent squared x. Okay? So when I do that, this is tangent x times 1 minus tangent squared x. Yes. Distribute that. What do you get? Tangent to the third x. Because tangent x times a tangent squared x is a tangent cubed x.
Oh, okay, yeah. Your square was kind of blended into your x.
this will have the same denominator as our first term. Can I write it as one fraction?
Yes.
Okay? Do you see anything?
It cancels.
You can add the 2 tan x.
Yes, I can combine like terms right here. 2 tan x plus tan x is a,
3
I have a 3 tan x minus tangent cubed x all over 1 minus tangent squared x equals 0.
Can we make the 2?
That'll be kind of going backwards.
Oh,
You factor out, it
Is
ends
it
up
the bottom?
canceling.
You can do.
Yeah, factor out.
I'm hearing a couple of different things. One thing I hear, you said something about an identity? Something about the bottom?
Oh yeah. Can be like.
Yeah, but then that would just turn it into.
Yeah. This, even though this is a variation of one identity, don't turn it into whatever its identity is. Why? Because you have all tangents here. Once you use an identity, you're changing it to another trig function, and that's just going to mess you up.
Pull out a tangent x.
I can definitely pull out tangent x from the numerator. That's definitely something I can do. I heard something on this side.
You can just multiply by the bottom and cancel it out from both sides.
This is a rational function. I know we did rational functions at the beginning of the year, but when you're solving this and it's equal to 0, multiplying both sides basically gets rid of your denominator.
Oh.
So then you'll just have a 3 tangent x minus tangent cubed x equals 0. No more fractions.
And then this, factor tangent x after that.
Yes. From here, I can factor out a tangent x because they both have it in common. We're back to solving. Lesson 7.3. When I factor that out, what am I left with? What do you do from here? Set it equal to 0. Set both things equal to 0. I am going to span off to this side, and then I'm going to clear this problem out, and then do number 2. I'm tired of going down. Questions up to here? Tangent is what over what?
I don't know.
Sine over cosine, or y over x. Where on your unit circle is tangent equal to 0? Then when you divide the y coordinate by the x coordinate, you get 0.
Pi over 2 and 3 pi over 2. Or 0 and pi.
It's going to be a 0 as well as pi. Since tangent is y over x, you want the combination where y is going to be 0 and x is going to be 1. If it was the other way around, it would be undefined.
Was it ever be one undefined?
Not when you're solving. Not to ask where is tangent x undefined, like it's a different question. Yes, sir. Yes, I'm recording right now. What about this one? How do I solve this one?
Subtract 3 on both sides.
Subtract 3 from both sides. Get the tangent by itself.
Wait, I thought.
And
I thought 3
carry the
is
negative
times-
over.
Divide by a -1.
And the square root.
And then square root. Please remember that when you square root both sides, it's a what?
Plus or minus.
Plus 4 minus.
And then you have to check for a straining solution.
That's only if you are squaring, not square root.
Oh yeah. Why am I so?
Now this one, you have to determine where is tangent a positive or a negative square root 3 on your unit circle. So, one of the places is at pi over 3.
Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Then it becomes negative.
Oh,
It's
I knew
positive and negative.
every single
That's why I said once you know one, you'll know the other ones because it's going to be the same angle in the same spot just in each quadrant. So you have 6 answers here. 0 and pi,
Oh.
and then the over 3s. With number two, we have cosine 2x and then 5 sine squared x minus cosine squared x. Double angle identity needs to be used for this one, but out of the three, which one do you think would be the easier one to use? The first one, cosine squared x minus sine squared x. After this point, it's a matter of just solving. What do you want to do here? Put them on the same side? Everything? Okay. So I'm going to add a sine squared x to this one. What does that turn into? And I'm going to subtract a cosine squared x on both sides. What does that turn into? All these things equal 0. I subtracted it. Now what? What can I do? I can't factor out a 2. What else can I do? I cannot factor out an x squared. That x is attached to the sine. Or the cosine. Which identity? Oh no,
You can make it equal to 0.
Okay. I heard something about the Pythagorean identity. Careful, that's sine squared x plus cosine squared x. And it wouldn't be a negative one unless both of them were negative. So can't use that. What else did I hear? I heard something. I can change either one of these so that it matches the other. Doesn't sine squared x equal 1 minus cosine squared x? So I can. No, which ones do you have to remember? The basic ones. Your double angle, your half angle, and your sum and difference ones, those will be given to you. But the basic ones, yes.
Does 0 equals 9?
Say again.
For these problems, you must use these. And then, like, you have to remember that you can also use, like, possibly use those. That's like.
Okay. Now I'm just going to simplify this a little bit. Distribute the 3. Combine like terms. And now, Tanner, what can I do? I could. 0 product property. If I distribute, that's fine. But since I already factored it out, I can just set both factors equal to 0. Now, when I said 2 equal to 0, is that anything important? No. It's just going to be that 3 minus 4 cosine squared x equals 0. Can you guys go ahead and solve this one out and give me my solutions?
Yeah, I was just trying to think of the other four. You can't do the like plus pi over 2 any
Right.
It's limited.
Right.
That's what I was thinking. That's what I was thinking. Because I don't have any.
You take the square root of both sides. When you square root the fraction, it's like you're squaring the top and the bottom. Don't forget it's a plus or minus. It should have been the square root of 3 over 2. So you're trying to figure out where is cosine a positive or a negative square root 3 over 2. That happens in 4 places, and they are. Those will be your answers.
I still going to be answer.
Same restrictions. I personally like the sine double angle ones because there's only one identity compared to 3 that you could choose from for cosine, and there are no fractions like for tangent. Okay?
We're just doing.
We're actually just gonna do these two because I realized the next one is a repeat of the first one. Okay?
What is that just sine is equal to sine x? Or is it something different?
It is just sine x. Alright, so this will be the last ones for double angle. So we have sine 2x, secant x, plus 2 cosine x. Now, this doesn't necessarily have to be in parentheses. It could be without the parentheses. So don't let that throw you off. I can replace this with the identity. What is the identity? So I've used the identity. Now I just have normal sine x's and a cosine x. I got a secant in there. What can I do with that secant?
1 over cosine.
A good old reciprocal identity to help you out. Now you have everything in terms of sines and cosines. What do you see? You can cancel out the cosines. Yes. The cosines cancel out. Just one of them. This one. Is everyone okay up to here? Well, from here, you could go a couple of different routes, okay? You can factor out a 2, but then you're still presented with the sine x plus cosine x, so then it's like, what do you do from there? You could square both sides. That is an option.
You know we shouldn't have done
Huh?
that. We shouldn't move the cosine over so we square both sides. We don't have to like.
That's actually not a bad idea. Y'all hear what she said?
No, I couldn't tell between the lines.
If you move the cosine over, that turns into a negative cosine x. Since they both have a 2 on each side, when you divide by 2, what happens? It goes away. So I divide both sides by 2. So now if you did want to square both sides, you know, now it's not like you have a binomial to FOIL. It's just square sine, square a negative cosine, and then go from there.
Wait, you're gonna do that?
And then what do you think you can do after you square both sides?
Pythagorean.
Square root both sides.
Use a Pythagorean identity.
No, why would we square the signs?
Wait.
It's okay. Okay, hold on. If from here, one thing that you can do is to square both sides. When you square it, this will turn to a sine squared x. This will turn to a cosine squared x. Then you can use the identity.
Add it over.
But how would you use that
But I thought
identity if
it was-
you have to
No,
switch
it
Okay.
both sides?
First off, you just another method that you can use is since you have a sine on one side and a cosine on the other, what you can do is you can, and I already know y'all gonna be like, but wait, you said, listen to me. You can divide both sides by cosine. Now, you can do this here, but you couldn't do it in those other problems that I was trying to make sure that you guys didn't do. Because when I divide by cosine, it's not like on this side I'm canceling out it with another cosine. I basically created what trig function? Tangent. So I haven't lost it. Okay? So, by dividing both sides by cosine, what's a negative cosine divided by a positive cosine? And sine over cosine is a. Now you're just asking yourself, where is tangent x a negative 1?
Wow.
Not power 4.
7, 5, 2, 5.
3 pi over 4.
3 pi over 4 and
5, 5.
So why wouldn't you divide by a negative?
No,
wait, hold on, I'm looking for the next one.
no, it'd be 7, 5.
7 pi over 4. Okay. Now the reason why I wouldn't divide by a negative cosine because then I would have a negative tangent x equals a positive 1. then I'll have to divide by -1, and then I'll basically go backwards.
Can we get the whole square thing again? Because I'm doing that and I don't know.
How should we start with number 4?
Make it 2 sin x cosine x times cosine. Do the sin x equals sin x.
Okay. Yes. You can do that. That would make it just a tad bit longer.
Then you just.
If you just subtract the sin x to.
I was gonna say that.
I know you just see.
You scared me.
No, I'm like,
You're very intimidating.
no, I'm not.
And you combine like terms.
Can't combine like terms here,
Oh, because it's sin.
but you can what? What?
So sin x.
A sin x out. I'm gonna let you guys take it from here. Give me my solutions. Don't shout it out when you have it, but give me my solutions. When you add 1, divide by 2, and then take the square root, it would be 1 divided by the square root of 2. You would have to rationalize. That's where the square root of 2 over 2 comes from. And of course, do not forget plus or minus. So where is sin x equal to 0? So there are 2 of your solutions. Where's cosine a positive or a negative square root of 2 over 2? So you should have a total of 6 answers. So these are your half angle identities. Okay, these are identities that you do not have to memorize. You just need to be able to apply them. Okay, these are used to solve equations as well as find exact values. Mostly for finding the exact values. And we're going to do a majority of our examples on that. We're going to do 4 examples of finding exact values, and then 1 with its solving. Okay? Does everybody have their values down? Not values, I didn't know something. Here we go. We got 5 examples. Here's the first 2. We are finding the exact value of each. Tangent pi over 8 and cosine 105. Now we're using half angle identities to find these exact values. If you were to use like your sum and difference to find the exact values, it would be a little bit more,
Why can't you go
harder.
Huh?
Because we don't have this is the angle that's attached to tangent. So there's no way that we can create a triangle to try to figure out what's the opposite adjacent. We don't have that information. Yes.
So is pi over 8 your u or is just
Pi over 8 is actually what equals u over 2 in that formula. So to figure out what is it that u is going to be in our formula, we have to set the angle equal to u over 2 and then solve this out. How do you solve this? So that's 8u equals 2 pi. How do you solve for u? Divide by 8. So that's going to be pi over 4. Pi over 4 is the value of u that goes into that identity. Okay?
Why would you equal it to u?
Because since we're trying to find the exact value, we're using half angle identities. Like when we do the tangent of pi over 8, the half angle identity is basically tangent u over 2. So we're basically matching this up with this.
Why would you use the equation as a or that component has to run down?
Well, that's the thing. Like the u is the angle, and we don't know that. So that's why we set it equal to u over 2 to figure out what is the angle that we let's get it plugged in. Okay. So now that we know u, use the identity for the double angle. out that u is pi over 4. So we're going to plug that in. Now as you circle time, what's the cosine of pi over 4? So we have a 1 minus square root 2 over 2. And the sine of pi over 4 is square root 2 over 2. No. Cannot leave it like this. It's algebra, and you have to simplify this. But you can't keep change flip just yet, because you have a 1 here. You have to make this one fraction, the numerator one fraction, before you can keep change flip. Here it is again. Yes.
Would you minus 1 to like, okay, so you make it equal to 0 and then minus 1?
We can't set anything equal to 0 because it's not an equation. So we can't do that.
You can change the 1 to 2 over 2 and then just put it in the 1 fraction.
Yes, you can change the 1 so that it has the same denominator. So that's basically going to be a 2 over 2. And then you can write it as one fraction. So then that will be 2 minus the square root of 2 all over 2. At this point, it's algebra. We are simplifying this complex fraction. Now, we can keep change flip it because we have one fraction being divided by another fraction. Keep change flip. These 2's cancel out. And only these 2's. Why doesn't square root 2 cancel out? Because it's connected. Very good. So you have 2 minus the square root of 2, and you have to rationalize. I know you're like, well, Jesus, Miss Anderson, this is exact value. Okay? You do have to rationalize. So you have to multiply the top and the bottom by.
Wouldn't that get rid of both?
Nope.
I'm gonna get rid of one but not the other. This doesn't seem fair.
When you distribute.
Would it be 0 over 2?
When you distribute 2 times the square root of 2,
Oh,
2 square root 2 minus 4.
square root of 2 times the square root of 2,
minus 2.
Yeah, minus 2.
all over.
2.
And what happens with these 2's? So your final answer is the square root of 2 minus 1. That is your exact value for the tangent of pi over 8.
That is exactly.
So you can cross out that 2 with both of them?
Yes, because if I wanted to split up this fraction, this would basically be 2 square root of 2.
Oh.
And that's why that can happen.
It's only because it's the 2.
And only because it's divisible by 2.
Okay, so yeah, so it's like a 3 or something.
Question?
That step, could you not have separate, like, wrote it as 1 over square root 2 over 2 minus square root 2 over 2 over square root 2 over 2?
Yes, you could do that.
Okay, that's what I did.
That would also work, yes.
Was that way?
I was gonna ask you, but that's the thing.
Five, four, one.
The 1 was there.
Write 5 on this paper?
It's not that hard.
You don't have no space.
Just write a little large.
Just too many steps. I was trying to.
Go.
Alright. Let's do the next one. It's cosine of 105. Cosine of 105. 105, that's not a unit circle. We're using half angle identities to solve this. So we need to figure out the u in the formula.
You can just change it to, the radians.
I mean, you can, but aren't there degrees on a unit circle too? If you want to, you can. You don't necessarily have to. We're going to set 105 equal to u over 2 to figure out what is u. To find u, all I have to do is, what is 105 times 2?
250.
So that is the u. That gets plugged in. So your half angle identity for cosine is a plus or minus. Now, before we tackle the inside and the simplifying of the inside, we need to figure out if it is indeed plus or if it is indeed minus. Look at the angle, the original angle, 105. What quadrant is that in? Second. 105 is in between 90 and 180. In the second quadrant, is cosine positive or is it negative? So, this is actually going to be a negative square root of all this. Okay? Now again, you determine if it's positive or negative, looking at the original problem, the original angle, and determining what its sine value is inside of like the unit circle. What quadrant is it? Yes.
This is equal to 0 right now.
No, it's actually equal to
First.
that. We're finding the exact value. What is the cosine of 210?
So we always have to check.
Okay, question. Say again.
That we always have to check what quadrant the original is in.
Yes, because that's going to tell you your sign. And you can't say that's plus or minus. And so what?
That's what I'm saying.
It's negative square root 3 over 2.
Oh.
We do have to simplify. Let's do it the way Ms. Casey did it, okay? Another way you can simplify something like this is because since this is two terms over one term, you can split it up. That's 1 over 2 minus the square root of 3 over 2 all over 2. Question. This is another way to simplify this. This is another way. Okay? Now, I can keep, change, flip with just this part. Keep, change. When I flip 2, what does that turn into? So that is a square root of 3 over 4. So I have a negative square root of 1/2 minus square root of 3 over 4. Can I subtract these the way they are? I need a common denominator of a 4. So this is going to turn into a 2. So this is now a negative square root 2 minus the square root of 3 all over 4. Remember, when you square root a fraction, you square root the top and the bottom. What will the bottom turn into? So your final answer the exact value cosine of 105 is what you see in the square.
Wait. So did you squared it? Give it a square root?
No, I square rooted the top and the bottom. When you square root a fraction, you square the top and the bottom. So that's why the top stayed underneath the square root, but the bottom turned into a 2. Question.
The 105 is an angle, right?
The 105 is the angle.
So usually a calculator would have that answer.
Your calculator would not have this answer. It will have the decimal version of this answer.
I mean, it's no calculator, so that's the
Yeah, that, and it is exact value, so you wouldn't be able to give me the decimal approximation. It would have to be this. Here's one with sine, okay? So again, you take the angle, and you set equal to u over 2. Cross multiply, and then divide. This reduces down to be 5 pi over 6. So that's the angle that you use to plug into the identity, okay? So it's going to be plus or minus the square root of 1 minus cosine 5 pi over 6 all over 2. Now before we go any further, where is 5 pi over 12, the original angle, located? It's located in the first quadrant. So because it's located in the first quadrant, you know it's going to be a positive square root. Again, you look at the original angle and where it's located. If you get stuck, think of it like this. Pi over 2 is 1/2. Pi is 1. 3 pi over 2 is 3/2, and 2 pi is 2. When you divide 5 by 12, is that less than 1/2, less than 1, etc., etc.? That will help you figure out what quadrant is. So now we simplify. Cosine of 5 pi over 6 is a negative square root 3 over 2. So because it's a negative, turns that into a positive, divided by 2. You can simplify this any way you feel comfortable. You can split it up, or you can get a common denominator with the numerator. You can keep, change, flip, and then you apply the square root to both the top and the bottom. So your final answer is going to be the square root of 2 plus square root of 3 all over 2. All right, here's another one. That's 112.5. Set it equal to u over 2. Multiply both sides, and you get 225. That is the value of u. So that's going to go into your formula, cosine 225 over the sine of 225. And the beauty about this, don't have to worry about any pluses or minuses with tangent. The cosine of 225 is a negative square root 2 over 2, but then that will turn into a positive. The sine of 225 is a negative square root 2 over 2. You can do the whole, get a common denominator in the numerator, keep, change, flip once you get the one fraction, like how we did in number 8, or you can split it up. It is your choice. You'll get the same result no matter which way you do it. For this first fraction, you can keep, change, flip. That will turn into a negative 2 over square root of 2. This whole fraction turns into a negative 1. You do have to rationalize this particular part, just this part. So that's going to be a negative 2 root 2 all over 2. The 2's cancel out, and so your exact value for the tangent of 112.5 degrees is negative root 2 minus 1. It really is all algebra once you figure out the cosine or sine or tangent of your angle. The last example is one where you find the solutions using your half angle identities. These are more rare. You're more likely to find the exact values versus solving, but I want to show you guys this just so you can have it for your notes. Now, to solve this, these are both squares right here. These are both squares. This whole side can be written like so. And you want to write it like that so you know that you're going to be squaring this particular identity. That is a half angle identity. That is plus or minus the square root of 1 minus cosine x all over 2. You are squaring this entire identity. Now, you know that when you square a square root, they cancel out, which means that that plus or minus is gone as well. So you're just left with 1 minus cosine x over 2 equals sine squared x. Now, this should be familiar to you guys. It's a normal equation that you can solve. I have sines and cosines together, so I can rewrite this as 1 minus cosine squared x. And then just solve. Multiply both sides by 2. Distribute the 2. Get everything on one side. And then you have a problem that you can just factor and solve. there are your solutions. Any questions that you guys have, make sure you bring them to class.